Hello, welcome back to my channel. Here we are discussing about a subtopic of today's qualitative analysis. Particularly, qualitative analysis is a type of pharmaceutical analysis where it is again divided into qualitative analysis and quantitative analysis. Quantitative analysis is nothing but where in a solution we are determining the amount, concentration of the analyte present in that. So qualitative analysis is again classified into volumetric analysis, gasometric analysis and gravimetric analysis. Particularly, volumetric analysis is a term, it's an analysis in which a volume plays a major role. In gravimetric analysis, mass, weight of the final pure compound plays a major role, and gasometric analysis is nothing but the amount of gain of absorption and release of gas takes place. In these all three terms, majorly we are discussing on the topic called gravimetric analysis, and it is most important for your 10 marks for your examinations. Then what exactly gravimetry means? That is a question mark, right? Gravimetry is an analytical method, yes, we do agree, in which the amount of analyte, yes, analyte is nothing but a test sample whose concentration, whose amount we need to determine is determined by measuring its mass. As I said earlier, mass plays a major role in gravimetric analysis. After converting it into a pure, stable compound, then how exactly what does it mean by pure, stable compound? Yes, so here comes the steps. In this entire steps, we will come to know what exactly the pure stable compound known by and how exactly we are determining the mass of the final compound, and that mass is how related to the amount of analyte in a given solution. So steps involved in gravimetry. What will be the first step? Preparation of solution. What we are preparing. So in this diagrammatic way, I can explain you that how exactly the steps will be related. Preparation of solution. So what solution we are preparing? I'll take the analyte of unknown concentration and I will be dissolving that analyte into a suitable solvent in which the analyte will be easily dissolving. That itself will be known as preparation, and the preparation of solution should be homogeneous in nature. And what will be the second step? Precipitation. What precipitation? We are formation of precipitation takes place. Then can the solution of analyte will directly go into a precipitation formation? No, exactly. For that we need to add the precipitating agent, and the choice of precipitating agent will be totally depending upon the nature of analyte we are determining. So in the solution of analyte, I am adding the precipitating agent. Just for example, I'll tell you that we are determining the amount of analyte chloride. For this, I am choosing AgNO3 as a precipitating agent, and directly we can have AgCl as our precipitate, and this precipitate itself will be the formation of precipitation, and whatever the AgNO3 is I'm adding is nothing but the precipitating agents which will be going to help in the formation of precipitate. So second step has been completed, and the third step will be digestion or aging. Then how exactly digestion and aging can be described in gravimetry is that whatever the precipitate has been formed in the second step, the crystals of precipitate will not be much bigger enough. To make those crystals bigger enough, we are moving for the digestion. So in digestion, what happens? We are keeping the solution, we are keeping the precipitate to be there for a longer period of time under the heating conditions, and that itself will be digestion. Then why we are keeping our precipitate in a heating conditions? So as I said that whatever the small crystals are there, that will be going to dissolve again in the suitable solvent, and they will be deposited on the surface of large crystals. Thereby what happens, the 100% of bigger crystals of precipitate will be formed, and the greater the crystals, greater the size of the crystals will be, the greater the weight, greater the precipitate formation. And what exactly aging means? Aging is also same like digestion. We are keeping our precipitate to be there for a period of time, but with or without the heating conditions. That's why digestion is more faster process as compared to the aging. And then we'll move to the next one, that is filtration. Okay, we got our precipitate, and that precipitate should be go for the filtration. That is nothing but the separation of precipitate from its mother liquid. And that is, for that we require a filter media. We can take either crucibles or filter papers depending upon the nature of the analyte we are determining. After the filtration, our major task is, the major important thing is precipitate itself, and we are not considering the mother liquid. These are all the things. Okay, so after that the next process will be washing. The next process will be washing. So in washing, what happens, whatever the precipitate which we have already filtered, we'll take it in a crucible or a beaker. In that we'll add our precipitate, and with that we are adding our washing solutions. The washing solutions can be either water if the nature of precipitate is independent of the aqueous matter, or else we are adding some of the agents which will prevent the degradation of the precipitation, precipitations. So for that we are taking some of the suitable washing solutions which can clearly remove all the carbonaceous matter as well as all the impurities and also the trapped mother liquid from the compound. So why we are going with these all the procedures means we require pure and stable compound, and that pure stable compound we are weighing, and the mass is equivalent to the amount of analyte present in the solutions. The next step will be drying. Okay, we have washed the solution precipitate, and then next obviously the step should be drying itself, where the drying is nothing but keeping the precipitation, heating the precipitation under less than 250 degrees Celsius is called as drying. And the ignition is quite changes from the drying, where we are burning the precipitation from more than 250 degrees Celsius to 1300 degrees Celsius in a suitable heating apparatus, and that will be ignition. The purpose of drying as well as ignition is to remove all the water content, all the washing solution content, as well as all the carbonaceous matter impurities which are left over in the precipitations. Those all the things can be prevented, can be removed by drying as well as ignitions. Now we can say that whatever the precipitate is formed, now it is highly pure enough and highly stable enough after going with these all the steps. Finally, the final step will be the weighing. We are weighing the pure stable precipitate into a suitable weighing balance, and that weigh will be noted down. The next step will be calculations, whereby using a suitable formula we can calculate the percentage or the amount of analyte present. And this formula we are using for the calculation amount of analyte. Here we are not using a term called concentration. The concentration term will be applicable for volumetric analysis. The amount of analyte is equals to weight of precipitation. Obviously what we have weighed, that amount, that value we are taking, and is equals to molar mass of analyte. What is a molar mass of analyte? I have taken an example of this Cl. We need to know the molar mass of chloride. What is the molecular mass of chloride? That itself will be the molar mass of analyte, and molar mass of precipitate. Obviously we know that AgCl precipitate will be formed. In this we need to calculate the molar mass of Ag as well as Cl. Okay, so that value we need to put it all here, and that will give our amount of analyte. and these all the steps will be going to be followed one by one. Thereby we can easily calculate the amount of unlight present in the given solutions. Thank you.